Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. This next section is all about safety. Soldering irons get extremely hot enough to make molten metal out of soldering wire. This molten metal can drip and splatter, so always be aware of your surroundings and always use an improved cradle for your soldering iron. Always be conscious of your surroundings. Never solder next to highly flammable materials, and always wear safety glasses. The vapors produced in soldering are highly toxic, so always solder in a well-ventilated area, and if necessary, use an exhaust hood. Electronics can become complex quite quickly. Remember, if you're not sure of what you're doing, stop where you are and get a professional. Do not work with high voltage unless you're qualified to do so. Soldering can be really tricky, but with a little practice, you'll be doing simple repairs in no time.
When you're soldering, one of the first things you need to do is tin your wires or your surfaces that you're going to solder together. You don't want to just stick them together and then stick solder on it and expect it to work out. What you want to do is get the wire hot, and you want the solder to melt onto the wire. You don't want to just get the solder, melt the solder and then stick it on there. You want your wire to be hot, and you'll see it kind of. When you're soldering, one of the first things you need to do is tin your wires or your surfaces that you're going to solder together. You don't want to just stick them together and then stick solder on it and expect it to work out. What you want to do is get the wire hot, and you want the solder to melt onto the wire. You don't want to just get the solder, melt the solder and then stick it on there. You want your wire to be hot, and you'll see it kind of melt in and wick. The wire will actually absorb the solder, and that's a really good tinned wire there. Once your wires are tinned very well, you can turn them and make sure that they're tinned all the way around. Then it's pretty simple. Just try not to move it as you go ahead and get them hot, and then try to be as still as possible while it cools. It only takes a few seconds, but if you move it while it's trying to cool, you can get what's called a cold solder joint, which isn't what you want. So try to hold it really still. When you're soldering little bitty components like this little microphone or a transistor, you might not want to have your iron as hot as possible, and you might want to try to make it quick, because if you get these really hot, you might damage them, so be careful with that. So here's my iron. Just be sure to use the little sponge, get it a little wet before you start. That way when your iron starts getting junk on it, you go ahead and just clean it real quick, get a little bit of fresh solder on there, and you're ready to start working. And if junk starts building up, see some bubbles there, just so one thing to note is whenever you're soldering, you get extra solder on your tip, you'll want to go ahead and shake that extra solder off. But usually when it hits the table, it'll dry. This has a pretty big glob. It's still a little wet, but it'll dry, and you can just pick it off, and usually doesn't hurt your countertops. Notice that I have this little fan here. It's not really good to breathe as much smoke as possible, so I made this little whisper quiet fan. It's just a quiet PC fan, but I wanted something really quiet but it would still make a little bit of a breeze, get the smoke out of your face so you aren't just breathing it. So when appropriate, it's good to have I think it's called a helping hand, to help hold the things you're working on, because you don't only have so many hands. Here I'm going to go ahead and prepare the surfaces by tinning them really good with some fresh solder. And you can tell my iron is definitely hot enough to get the solder on there, and if your iron isn't hot enough, you might have trouble getting the solder to tin on there right. So the temperature, having a good temperature on your iron is important. Trim them up a little bit. Apply the two surfaces here. When you're troubleshooting a board and maybe there's intermittent issues going on, you might check people's solder job and see and make sure that the solder's holding. I found one here. It's a good example of a cold solder joint. It's actually, there's something here that could wiggle, but not always just stuff that wiggles, and you can see that there's a break in the solder. A lot of times they're really hard to spot, but you'll notice that even when it's down close, there's like a little ring around it. There's like a little line that once you see a few of them, you'll be able to detect them and know that you need to just slap some new solder on there and fix it up. Alright, I'm going to really show you what happens when you're not hot enough. Here my iron is hot enough to melt the solder, but you can see I'm having trouble getting it on there. It's because the iron isn't heating up the metal. You want to heat up the metal and then apply the solder to the metal. So look, that didn't even stick. It's just not hot enough. My iron isn't big enough. Alright, so now I've cranked my iron up to about 800 degrees to see what happens. First thing you want to do is get a little solder on your iron so it can make contact with your wire. Then you want to get your wire hot enough, and then you can actually put the solder not directly on the iron, but probably down on the wire. This thing is so huge that I probably shouldn't be doing it with this small of an iron. But there, it's starting to get warm. You can see the solder is actually starting to stick. It's not going to just fall off.
Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. One practical use for your new soldering skills is cable repair. This is an instrument cable. It has a shielded outer wire and then an insulated inner wire. The inner wire is your actual conductor that carries your signal. The outer wire is your shielded grounded braid. Now the first thing I'm going to do is unscrew the ends and see. Hi, this is Jeff Naylor. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. One practical use for your new soldering skills is cable repair. This is an instrument cable. It has a shielded outer wire and then an insulated inner wire. The inner wire is your actual conductor that carries your signal. The outer wire is your shielded grounded braid. Now the first thing I'm going to do is unscrew the ends and see if I can spot any problems. I see we only have one conductor and there's no insulation, so this cable's probably shorted out. The best thing to do in situations like this is start over and do it right. One of the most important parts in ensuring the longevity of your cable is prepping the wires. You must strip the wires and tin them so they do not short on each other. I want to take off this outer plastic core without damaging the inner braided wire. Now I don't press down too hard, instead I keep on spinning until it comes off on its own. Now I'm going to take this outer braid and unwind it, gather it to one side of the cable and twist it together. Now we're going to do what we call tinning the wire. Now to tin this wire, we're going to take a dab of solder and put it on the tip of the soldering iron. This will help conduct heat between the soldering iron and the copper wire. Starting on the other side of the wire, we gently tap and allow the solder to be wicked in by the copper. This is a one-handed stripping tool that's going to allow me to just go above this wire and basically pull the trigger. Now that our second wire is exposed, we're going to tin it. So now that we've got our wires properly stripped and tinned, it's time to make some cables. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. In this section, we're going to show you how to put on all the different kinds of speaker connectors. We have Neutrik, we have banana, and we have 1/4 inch. We're going to start with a Neutrik connector. We have two threaded locks here that actually hold your cable in place. So now that we've prepped and tinned our cable ends, we simply slide them in and screw down these two screws. Hi, this is Jeff Naylor. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. In this section, we're going to show you how to put on all the different kinds of speaker connectors. We have Neutrik, we have banana, and we have 1/4 inch. We're going to start with a Neutrik connector. We have two threaded locks here that actually hold your cable in place. So now that we've prepped and tinned our cable ends, we simply slide them in and screw down these two screws and pull the sheath over it. On the side, this says 1+ here. This is going to be our positive wire. This is going to be the white cable. And on this side, they don't really have an indication for minus, but we're going to assume it's the opposite of plus. You just kind of drop them in here and crank down these metal tabs. Now this top piece just pushes down over where we just had our connections. There's your Neutrik end. Next we're going to install a banana cable. On the side are holes where we're going to thread our wire through, and on the top are two threaded screws that are going to clamp down the wire. So approaching from the side, we're going to take our tin wires and put them in. We're going to put them in on the side with this hole here. And if we were using smaller wire, we'd actually feed it through this hole. But since this is such a large gauge, what we're going to do is put the wires in here and then actually use a zip tie to tie these up firm here, because we don't want this vibrating around. We simply screw them down tight with a blade screwdriver. Now the most important thing about speaker cable is that your ends always need to be tinned. We see in these other connectors that even though we're not soldering the ends in, it's important to have them tinned so they don't short out. And we always have to remember the difference between instrument and speaker cable. Remember that speaker cable does not have an outer shield, while instrument cable does. In our next section, we're going to be discussing mic cables. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. In this next section, we will discuss the various tools and supplies necessary for soldering. Now, not all the tools seen here are required, but they sure make life a lot easier. First and most important is a soldering iron with adjustable temperature. There are many different brands you can choose from. Next, we have our rosin core solder. This is the most common type used in this type of repair. Hi, this is Jeff Naylor. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. In this next section, we will discuss the various tools and supplies necessary for soldering. Now, not all the tools seen here are required, but they sure make life a lot easier. First and most important is a soldering iron with adjustable temperature. There are many different brands you can choose from. Next, we have our rosin core solder. This is the most common type used in this type of repair. We have desoldering braid used for removing solder. We have desoldering sucker, which uses a vacuum to remove solder. We have a set of small pliers, some hemostats, wire cutters, automatic wire strippers, razor blade, safety glasses, and last but not least, a bench vise. This was a basic overview of what I use on a day-to-day basis. Now it's nice if you have all these tools, but if you don't, the only tools that are really required for today's lesson will be the soldering iron, the solder, a pair of good wire strippers, and some kind of solder removal device, whether it be the braid or the solder sucker. Soldering seems simple, but you have to be prepared. In our next section, we're going to discuss safety. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. Solder is a mixture of metals designed to penetrate when melted and provide optimum strength when cooled. There are three things to consider when selecting solder. The first is whether you want lead or lead-free solder. Now, a lot of newer devices in the market use lead-free solder for environmental reasons. However, for technicians, lead-free solder is a nightmare. I can tell you, it's a lot harder. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. Solder is a mixture of metals designed to penetrate when melted and provide optimum strength when cooled. There are three things to consider when selecting solder. The first is whether you want lead or lead-free solder. Now, a lot of newer devices in the market use lead-free solder for environmental reasons. However, for technicians, lead-free solder is a nightmare. I can tell you, it's a lot harder to heat up and it doesn't penetrate as well. So for all my stuff, I use a leaded solder. The next thing we must take into consideration is whether we want our solder to be solid or flux cored. Now, flux core basically means that the solder is actually hollow in the center and they fill it with a detergent that prevents oxidation. Now, this is nice because if there's any contamination on the metal parts you're using, the flux core will help clean that away and help your components to adhere to each other. The third thing you need to consider while choosing your solder is the diameter. You want wire that is thin enough that it won't over cover the parts you're using. In all my experience, I have found that the optimum diameter for me is 63 thousandths of an inch. It is small enough so that I can do surface mount work, but large enough so it still fills in well on the hand-wired work. Now, the most common solder mixture used in tech work is 60-40. That means it's 60% tin and 40% lead. This mixture is strong, it flows well, and it melts quickly. Now, there are many different types of solder out there. The reason I focused on the rosin core 60-40 is just for its ease of use. If you do happen to get solid core solder, it'll be a nightmare to get it to adhere to the metal, and you will need a separate flux. So stick with rosin core solder, and if you can, stick with the lead solder. In our next section, we're going to discuss preparation and maintenance of your soldering iron. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. For basic electronic repair, a soldering iron with a pencil-style tip like the one I have here is preferred. You want something with a variable temperature so you can dial in the proper temperature for the work you're using. These generally come in power ratings between 45 and 80 watts. Now, the higher the power rating, the quicker it will get to temperature, and the more constant the temperature. Hi, this is Jeff Naylor from M-Tronics in Mesa, Arizona for Expert Village. For basic electronic repair, a soldering iron with a pencil-style tip like the one I have here is preferred. You want something with a variable temperature so you can dial in the proper temperature for the work you're using. These generally come in power ratings between 45 and 80 watts. Now, the higher the power rating, the quicker it will get to temperature, and the more constant the temperature will be. You can get an assortment of tips for this depending on what type of repair you're going to do. I prefer a small, narrow tip with a flat nose on it. This tip right here is one of the smallest you can buy. It's used in detailed work, like removing surface mount components from circuit boards. It's not good for general work because it's so small it will eventually burn up. This tip right here is a general medium point tip. It's good for most hand-wired electronics and will last a long time. I use a tip that's in between the two tips we just discussed. It's good for getting to tight spots, but it's also great for larger hand wiring. There are many different types of soldering irons that can be used, from butane torches to the simple wand that you plug into the wall to your grandpa's old pistol grip with the trigger on it. These will all work fine for today's application. The only type of soldering device I do not recommend you use are the cold heat type. In my experience, they have not worked well for me. Now that we've discussed different types of soldering irons, in our next section we're going to discuss different types of solder. See you there.
Alright, we're going to start out by taking a 20 gauge piece of wire. We're going to strip it. I'm going to 20 gauge on the wire mechanical strippers. I strip and I just get it started. I release it. And then so I don't disturb the strands, I'm going to twist and pull so I keep them all nice and wound together. Should look just like that. Alright, we're going to start out by taking a 20 gauge piece of wire. We're going to strip it. I'm going to 20 gauge on the wire mechanical strippers. I strip and I just get it started. I release it. And then so I don't disturb the strands, I'm going to twist and pull so I keep them all nice and wound together. Should look just like that. Now what I need to do is clean the wire. I'm going to take my alcohol, clean it, and so it doesn't oxidize, I'm going to add flux lightly. Add the flux. I'm going to place it into my wire holder. And I am all set and clean. The next thing I need to do is get the solder prepared. I take my solder. Don't use your iron to burn a chunk off. You need to cut a chunk off. You cut it, and now you need to clean it. You clean the solder with alcohol and a chem wipe. It's clean. The next thing I need to do is clean the iron. I clean the iron by taking a chem wipe that does not have alcohol on it. I clean it by wiping it into the trash can. I removed the solder, but I did not remove the oxidation. So to remove the oxidation, I now use the sponge. Please don't wipe the sponge full of solder onto the soldering iron with solder onto the sponge, because you're going to destroy the sponge. So clean the sponge, just go on an edge, remove the oxidation, then come to your connection, dab the solder onto your tip to tin it. Then I am going to form a solder bridge. I form a solder bridge by applying the iron to the wire and just form a little bridge of heat. And then I take the soldering iron slowly up the wire, but not all the way into the insulation, and then back down the wire. That tins the wire and removes any excess solder, pulls it onto the hot iron. And then I lightly tin the iron to protect it, place it back in the holder. The only thing I have left to do is to clean the connection. I clean the connection by taking my stiff bristle brush and cleaning any flux residue to prevent corrosion. I cleaned it, and now my wire is tinned. I do not have excess wire up the insulation, and the strands are still showing. I should still be able to see the strands. I do have a little bit of excess solder on the end here, but it's not too bad. Did that turn out?
Mm-hmm.
Alright, we're going to start out by stripping the wire using mechanical strippers. If you go to page 3 of your NASA handbook, we're going to take our wire on step 3 using our mechanical strippers. I'm going to take my 20 gauge wire, place it in the 20 gauge slot. I'm going to press until it just pulls the insulation away. Then I'm going to release back. Alright, we're going to start out by stripping the wire using mechanical strippers. If you go to page 3 of your NASA handbook. We're going to take our wire on step 3 using our mechanical strippers. I'm going to take my 20 gauge wire, place it in the 20 gauge slot. I'm going to press until it just pulls the insulation away. Then I'm going to release back, leaving the insulation still on the wire. The whole key is to twist and pull to keep your strands all tightly formed. The next thing I want to do is clean the wire. I'm going to clean the wire because now I'm going to use my solder pot to tin it. If I turn the next page, go to step 1 on page 5, I strip the wire. Now I'm going to clean it and then use my solder pot to tin the wire. I'm going to clean my wire. I'm going to take my wire brush, lightly brush without disturbing or combing out the wires. I'm going to clean the connection. Then I'm going to immediately flux. I flux the wire in order to keep the oxidation away. And then on top of the solder pot, I don't know if you can take a look at what the solder pot looks like after sitting here for a few minutes.
Yeah.
Dross accumulates on top of the solder. You do not want to stick your wire into that mess. So the first thing I'm going to do is clean the dross off. I clean it, remove it, and just put it right here on the tray. And it immediately begins to form. And this may be too hot. I might have to turn it down a little bit. But I'm going to give myself a nice clean area. I'm going to take my wire that's already prepared, and I'm going to make a figure 8. Not going all the way up to the insulation, just leaving a slight gap. Pulling it out. And now my wire is tinned. It's tinned, but however there's still flux. There's flux, and I left myself a little 1/2 millimeter gap, approximately fingernail width, so I don't want that wire to wick up underneath my insulation. When I'm adding the flux, ideally I try to keep the flux from going up under the insulation. It's not always practical, but that's your goal in life. So the solder does not wick up, and due to capillary effect, gets sucked up into the insulation and become very stiff and brittle. Now the wire is clean, and it's tinned. Alright, we're now going to take a wire and connect it to a hook terminal. So we'll have Dudley start us out with the steps.
Alright, step 1B, insert a terminal into a phenolic block.
Alright, done.
Step 1C, clean the terminal.
Alright, so I'm going to take my alcohol, lightly clean the terminal, and then add my flux. Alright, we're now going to take a wire. And connect it to a hook terminal. So we'll have Dudley start us out with the steps.
Alright, step 1B, insert a terminal into a phenolic block.
Alright, done.
Step 1C, clean the terminal.
Alright, so I'm going to take my alcohol, lightly clean the terminal, and then add my flux.
Step 1E, clean the iron.
I'm going to clean the iron. Solder is removed. I'm going to remove the oxidation. Okay.
Step 1F, tin the terminal.
And tin the terminal. Lightly tin the iron first. Create a solder bridge at the back of the terminal. Add from the front end, it comes back, and it's tinned.
Step 1G, place the solder wick on the solder. Remove the solder from the terminal.
Alright, so now I need to remove any excess solder that happens to be on the terminal. Doesn't look like there's a lot there, but we're going to give this a shot. I'm going to take the solder wick, add flux, lightly flux the solder wick. You have a nice little layer. And then in order to remove this, what I need to do is add solder from the iron to the wick to form a bridge, and then add that to the terminal itself. So I'm gonna lightly clean my iron. I am now going to add solder to my soldering iron, and then I'm going to add this solder to the wick itself, and finally this solder will make a bridge onto the terminal. And then I just wipe it around just like you would wipe a table with a wet cloth, and you can see that it removed any excess solder. Oop, I got to tin my iron before I place it in the holder. Removed any excess solder. The excess solder is now on the solder wick, and that should be solder free.
Step 1H, clean the tinned terminal.
I'm going to clean the tin terminal by taking my stiff bristle brush and my chem wipe so I don't make a mess, and just lightly scrub the hook terminal. Okay.
Step 1I, place the wire up against the bottom of the hook.
Alright, that wire that we tinned in the previous step, our previous subject, I'm going to take it and I'm going to place it up, that tin wire, place it up against the terminal. Okay?
Step 1J, wrap the wire tightly around the terminal. The insulation shall not be embedded in the solder joint and shall be less than 2 wire diameters, including insulation.
So what they mean there is my insulation, I do not want this embedded or touching the top of the hook terminal. However, I also don't want to have excess wire sticking out away from the terminal. So I cannot touch it, nor can I be more than 2 wire lengths away. If I take a wire, including the insulation, if I double it up and place it against the terminal, I can see that's a pretty good distance. So I'm going to use a single strand to get me right in between, to give me a good guide of how far I need to be away from that hook terminal. I hold that wire, including the insulation, up against the terminal, and now I'm going to form and bend around the terminal. Now these needle nose do not have any teeth, so it's not doing any damage to the terminal. Alright, next step, Dudley.
Step 1K, slide the wire off the terminal.
Okay.
Flush cut the bent wire so that it will only make contact with the terminal for a half turn to 3/4 turn.
Okay, what Dudley is saying there is that now that I have my wire bent around my terminal, I'm going to bend, and I want to be either halfway around the terminal to 3/4 of the way. Right now I'm halfway, so I'm going to bend a little bit further before I slide the terminal off. Between 1/2 and 3/4. I'm going to slide off the terminal, and you can see that my connection. Now when I look here though, I want to know how much to cut. I don't want to cut onto the terminal because I may nick or damage the hook terminal. But I do want to grab it lightly so I know where to cut. I'm going to slide it off, and now I'm simply going to cut. Okay.
Step 1L, hold the cut wire against the terminal to check the wrap dimension. The wire shall contact the terminal for the full turn for which it is cut, and recut the end of the wire as necessary.
Alright, so I'm looking at my terminal, and I want to just because as I cut it, it can bend, so I just want to hit it up and reform it around the terminal if need be. I can hold it in place and just kind of bend the wire around the terminal. Hold it in place and bend. And just making sure it's all the way up against my terminal. Okay?
All right, now we're going to position the wire, attach the wire from the terminal to the spring, which will hold it during the soldering.
All right, so now I'm bringing my spring over to hold my wire. Whoops. There we go. My spring, and try to get it to hold over the top of my terminal. And ideally, I have it straight up and down. So in this case, I need to come up and bend it over, if possible. There we go. A nice arc. I'm going to check it again, looking to see that it's straight up and down, grabbing the terminal again, forming it, and then making sure mechanically it is connected all the way around the hook terminal, which it is.
All right, and now we're going to clean the connection.
So without disturbing your connection, I'm going to lightly clean the hook and the wire together. And then I'm going to add flux to the entire package. Okay.
Next, we're going to cut the end of the solder.
All right, so now I need to take my solder, cut a piece off. Don't burn it off. Don't cauterize it. You need that core to be exposed so you can have the flux that's inside the solder. I'm going to clean my solder with my chem wipe and alcohol.
Next, we're going to cut the end of the solder.
Okay.
And then we're going to clean the soldering iron.
All right, now I'm going to go through, clean the iron. Remove the oxidation.
All right, then we're going to position the iron.
Okay.
And then apply solder.
All right, so now I clean the oxidation again. Remember, you only have a few seconds before the oxidation begins to form or yellow on the iron. So I want to keep removing it, but what I want to show you here is I want to take this solder and I want to form a heat bridge between the hook terminal and the wire itself. So I'm going to clean it because it began to yellow. Now I'm going to tin and then create a bridge. Create a bridge between the two. And now, once you have the heat transferred, I can add solder to each end of the hook and to the wire. And then simply remove. Remove the solder first, and then hold for a second, and then remove the iron. Don't forget to re-tin the wire, or the iron, before placing it back in the holder.
And lastly, we're going to clean the connection.
All right, so now I want to clean the connection. I'm going to take a chem wipe, and then take solder onto a stiff bristle brush. Place this so you don't make a mess. You place it and wipe the flux off onto the chem wipe. And you got to use that stiff bristle brush because sometimes the flux likes to accumulate into the little joints. Now, when I was adding solder, after forming the bridge, I added the wire to each end of the terminal and to the end of the wire. It's going to flow toward the iron itself. And I cover any exposed copper. Any exposed copper on the hook terminal, any exposed copper on the wire, which there shouldn't be from tinning. And then you don't want to add too much. You just want a nice fillet between the wire itself and the hook terminal. We're going to inspect it. I'm going to slowly try to get this out of here, out of the phenolic block. I have flux that ran down, so I'm going to have to clean the bottom here. Clean the bottom. And then I'm looking at my connection. I don't know if you can see that. I'm looking at my connection and making sure that I have a wire attach to the hook terminal 1/2 to 3/4 all the way around the hook. A nice fillet, not excess solder. You don't want a big glob. I want to see the outline of the wire, and I want to see the outline of the hook throughout the entire connection, which I do. And then again, not a big glob, and as long as you can see the outline, that is a good solder joint. And no exposed copper, and no flux that's embedded into the wire. Also, you want to make sure that the solder didn't wick up into the wire, which it didn't. So it's a nice flexible joint right here at the end, and a complete connection on both sides, and it's very shiny. Shiny tells you that it wasn't overheated, it didn't move while you were soldering. And that's it. Alright, we're now about to attach a wire to a connector pin, a solder style connector pin. Go ahead, Jen, go ahead and read each step.
Step 1 is you're going to prepare the connection. A, prepare the stranded wire.
Okay, the stranded wire, I already pre-tinned it in the solder pod as we talked about in previous steps.
B, insert the terminal into the phenolic block.
Alright, I took my terminal, it's inserted into a phenolic block.
C, place the end of the stripped and tinned.
Alright, we're now about to attach a wire to a connector pin, a solder style connector pin. Go ahead, Jen, go ahead and read each step.
Step 1 is you're going to prepare the connection. A, prepare the stranded wire.
Okay, the stranded wire, I already pre-tinned it in the solder pod as we talked about in previous steps.
B, insert the terminal into the phenolic block.
Alright, I took my terminal, it's inserted into a phenolic block.
C, place the end of the stripped and tinned wire into the cup.
Alright, this wire, I stripped it long on purpose so you can see that I'm going to place it into the solder cup. Okay.
The insulation should not be embedded in the solder joint and shall be less than 2 wire diameters, including insulation.
Right, it's obvious that the insulation is not touching the connection. However, it is way more than more than 2 wire lengths. So I need to trim this connection. So I'm going to trim it down.
Remove the wire and use wire cutters to cut the wire to the desired length.
Alright, I'm now going to place my wire back into my terminal, and I'm going to check to make sure that my insulation is now not touching my top of my solder cup, which it isn't, and that it's no greater than 2 wire lengths, which right now it's at 1 wire length, so it's within that 2 range. So we're going to call that good.
Okay, D, clean the terminal with an acid brush using approved solvent.
Alright, I'm going to take my isopropyl alcohol, and I'm going to make sure that you get inside the hole, the solder cup, and then on the outside. Okay.
E, tin the terminal by inserting the end of the solder into the cup and placing the iron so that it touches the solder and the side of the terminal at the same time. Fill the cup with solder and cover all this inside surface.
Okay, so now I'm going to apply flux to the solder cup and to the, just let it run on the outside also. I want to remove the gold off the connector. In order to do that, I need to apply solder. So I'm simply going to cut my solder off. I'm going to clean my solder. I'm going to place it inside the cup. I'm going to clean my solder tip. I need to tin my tip. Place the solder back in the cup, and now touch both at the same time. And I want to make sure I get enough solder on the cup to remove the gold. Alright, and it's obvious that I cannot add a wire. Some folks would heat it up and insert the wire. We don't want to do that because that introduces a lot of contamination. So the next step.
F, to wick the solder from the terminal, insert a stranded wire that has been coated with flux. Position the iron tip against the wire. The wire will get hot and melt the solder, which will then wick up into the stranded wire. Cut off the wire that has solder wicked into it. Repeat the wicking process until there's no solder left to remove.
All right, there's a couple things we can do. I want to remove that solder. I can use a wire, another wire with flux to remove it. The first thing though, I have so much solder on there, I'm going to use a very thin wick to get it started. Use a thin wick. I placed flux on the wick. I'm going to clean my soldering iron. And I'm going to soak up as much of this solder as possible. Alright, I'm going to move it down. I'm going to make sure the outside doesn't have any globs of solder. So I can even lay it and kind of wrap it around. Soak it up. There we go. Looks pretty clean. However, there's solder in the bottom of that cup. Since there's solder in the bottom of that cup, I'm going to do exactly what they said. I'm going to take the wire. I'm going to strip it. I'm going to clean it. I'm going to flux it. And I'm going to place it inside the cup. And I'm going to wick out any excess solder. In order to do that though, I actually have to add a little solder to form a bridge and to soak it into the wire. I get the bridge going and I simply take my iron up the outside of the wire so the solder follows it up the wire and soaks it up and it leaves the solder cup clean. I'm going to tin my wire, place it back in the holder. I'm going to cut that piece off because that's junk. And I'm going to go to the next step.
Clean the terminal with the acid brush.
I'm going to clean it with an acid brush. First, I'm going to place the chem wipe over the top so I don't make a giant mess to soak up any excess flux. Getting inside and outside, as much inside as I can get. Make it nice and clean.
Step 2, you're going to position the wire, attach the wire from the terminal to the spring.
Okay, so I'm going to position the wire, I'm going to attach it to the spring. Before I insert the wire that I prepared, before I insert that, oops, this one. Before I insert this into the cup, I want to just hit it with alcohol, clean it. I'm going to insert it in, although I'm going to clean it again, but I'm going to insert it, I'm going to hold it, lay it over, and I want it going straight into the cup. So I'm going to get a little bend there, and it looks good. Okay.
Clean the connection.
All right, so now once again, I'm going to clean the connection with my acid brush, lightly cleaning it. Keeping that wire up against the back of the cup, a good mechanical connection. I'm going to try again a little bit further back. I want it against the back of the cup. There we go. Okay.
Step 4, you're going to cut the solder.
Okay, so I'm going to add flux. I'm preparing it to be soldered. I'm going to cut the solder, a new piece, cut it, clean it. Okay.
Step 5, clean the soldering iron.
Okay, now I got to get the iron prepped. I'm going to take a non-soaked wipe, wipe the iron, remove the oxidation. Okay.
Step 6, you're going to position the iron, place the clean soldering iron tip against the terminal so as to connect both the wire and the terminal at the same time.
Okay, so what I want to do is form a solder bridge, and I got to touch the iron and the wire at the same time and form a bridge by just dabbing a little solder between the iron, the wire, and the cup. I do not want to go against the back of the cup because it'll leave a little spike at the back. I need to form all three, then I'm going to touch it for about 3 seconds max, allowing the flux to bubble out. It'll bubble, And then I'll see it solid. I don't want to add too much solder because I want a nice concave connection in between the wire and the connector pin itself. I'm going to form it and then remove the solder, and then lastly I'll remove the iron. So I need to clean this again because it oxidized as I talked. I'm going to place this against the wire and the connector itself, form a bridge, and then add just enough solder, remove it, and remove it.
Step 7, now that we've applied a small amount of solder to the junction where the wire and the terminal and the tip meet, we've made a solder bridge. Now, step 9, clean the connection, clean the flux from the solder connection.
Okay, so we formed our bridge, we added our our solder. Now I'm going to clean the connection to remove that flux. Scrub dub.
Step 10, inspect the connection.
I'm going to remove it and make sure that I don't have excess solder, any solder spikes, flux. A million things can go wrong when you make these things. Make sure it didn't move. I don't know if you can see that. But I'm looking to make sure that I can still see the wire strands, which I can still see. I see the wire strands. I can see a nice fillet between the solder cup and the wire. And then to make sure that my insulation didn't shrink back more than 2 lengths from the connector pin, which it didn't. It's still at 1 length. If you overheat it, sometimes the insulation has a tendency to shrink back. And if it goes beyond 2 wire insulations, then it shrunk back too far. But that looks like a good connection. I just need to clean it up a little more. As you can see, it still has flux on the pin, which I can simply do by taking a chem wipe, cleaning the entire thing, and that would be a good connection.
Sweet.
Okay, today we're going to do through-hole components. We're going to solder resistors, capacitors, transistors onto a circuit board. This is our practice board. All the components are pre-tinned already. The board's tinned. I tinned them in the soldering pod in accordance with our video we did, I think video number 2 or video number 1 by hand. We're skipping that step. We're going to start out with the NASA handbook. Okay, today we're going to do through-hole components. We're going to solder resistors, capacitors, transistors onto a circuit board. This is our practice board. All the components are pre-tinned already. The board's tinned. I tinned them in the soldering pod in accordance with our video we did, I think video number 2 or video number 1 by hand. We're skipping that step. We're going to start out with the NASA handbook. We're on page
69.
69. We're on page 69, and we're going to go ahead and start out with step 1. Go ahead, Jen.
Step 1 is to prepare the leads. All part leads should be tinned and formed before mounting the part. Step 2 is to bend the leads with a lead bending tool. To find the correct measurement, place the bending tool between the holes into which the part is going to be inserted.
Okay, I'm taking the lead bending tool. I'm looking at my resistor hole that I'm selecting, R11. And I'm looking straight down on the board to see where the leads are going to wind up. If I put my lead through, put it up against there, and I can see that that hole is going to be about right. Let me check the next one. Ooh, that's even better. So I'm going to lay that down at number 6.
You're going to position the part into the proper slot for bending while holding the part body in the slot of the bender. Use an orange stick to bend the leads.
Here's my orange stick. It's nothing more than a wood chisel looking device. I'm going to hold my resistor down with my thumb and then use my orange stick to flatten it. And I want to make sure, as best I can, that the leads are bent and in line. Just press her down. Okay.
Insert the part. Step 3. Part leads shall be formed so that they will be installed into the holes in the PWB without excess deformation that can stress the part body or the end seals.
So I just cleaned it real quick again, just so I don't insert any contaminants into the board. That's a nice fit. So now I have my resistor laying in, and it's not deformed. It did not stress the leads as I put the resistor onto the board.
Step 4, you're going to trim the leads. Turn the PWB part side down. Place a measuring device on the PWB next to the leads in order to obtain the proper lead distance and cut the lead. Straight through leads may be bent up to 30 degrees from a vertical plane to retain parts during the soldering operation.
Okay, all I did there, I flipped the board over so the resistor didn't fall out onto the floor. I just want to bend the resistor down so it'll retain it. In order to check the proper amount of lead, what I need to do is use a device, which typically we use a resistor lead. Take a resistor lead, any resistor lead, bend it around, and that is going to be my calibrated measurement device. If I lay this resistor over, that resistor will allow me to lay my dikes over the top and clip the resistor lead at the proper length. Okay, so I laid it down 30 degrees, and now next step.
Clean the lead with a soft brush using appropriate solvent.
Okay, so before I clean it, I'm going to lay my resistor over, clip it. These are safety glasses. You want to make sure you wear safety glasses, and if all possible, hang on to the lead so it doesn't fly and hit your buddy. Lay it over here. Make sure my resistor is all the way up against the board. Lay that flat. Lay my diagonal cutters down, cut, and now I have the proper lead length sticking out of the resistor. Next thing. Oh, and clean. Okay, Jen?
Step 4, clinch the leads. Partially bend the leads in the direction of the trace. Cut the leads. Using an orange stick, complete the bend. The length of the clinched portion of the part lead shall be less than a half of the largest dimension of the solder pad, or 0.78 millimeters, whichever is greater. Fully clinched leads are defined as leads bent within 75 degrees or 90 degrees from a vertical line perpendicular to the PWB. Step 5, solder the leads. Position the solder iron tip so as to touch both the lead and the printed wiring pad at the same time.
Okay, I clinch the lead. I clinch the lead in the direction of the trace. So my trace is going this direction, so I'm taking the lead, clinching it down onto the trace. Same thing here. And I have to cover at least half the pad. So the lead is laying down and covering half the pad. This lead's a little long. I'm going to trim it a hair because it's going onto the conformal coating. Trimmed it. And again, clinching the lead. All right, lead's clinched. And I have to be 75 to 90 degrees clinched. There we go. I touched it again, so again I need to clean this lead. And it's clean.
Step 5, solder the lead. Position the soldering iron so that you touch both the lead and the printed wiring pad at the same time.
Okay, I cleaning the other side. It did not mention in the handbook if it's a single side or a double side board. This is a through-hole double side board, so you have to be sure before you solder that you clean both sides of the board. Not only do you clean both sides, you flux both sides. So I'm going to flux here, flux there. Then I need to turn over and also apply flux on top of the lead. So the solder is going to get hot, flow through from here. It's going to flow through onto the other side. So before I solder, I need to prepare my solder. Again, I cut the solder so I don't burn off a piece, so you don't cauterize it. You leave that hole open so the rosin flux can flow out of the solder itself and onto the joint. Now I have that flux. This is clean. The next thing I need to do is clean my iron, and I'm soldering next. Okay, so now I'm going to clean. I'm going to clean it, and I have this waste can. The waste can later, I'm going to take this lead and throw that into my lead contaminant container. But for now, it's going inside that box. Now looking at the tip, before I do that, I noticed the tip was pretty oxidized. It wasn't tin last. Since it's oxidized, I need to try to clean that. Let me try that again. There we go. That looks a lot better. Okay. Since I used that end, I need to cut another piece. Cut, clean it. Okay, now I'm ready to apply solder. So before I touch, since I've been sitting here, it's beginning to oxidize. You can see that it's changing colors. It starts turning yellow. So again, you got to go to your sponge and you just hit it a couple times, because every time you hit it, you'll watch your temperature drop on your soldering iron. Remember, that soldering iron has to maintain 600 degrees. So I again hit it again, and now I'm going to apply solder by barely touching the soldering iron, just a little dab, right? Just a little dab to tin the soldering iron. Then I'm going to touch the solder pad and the lead itself. And when I touch, I'm going to feed just enough solder to get a good fillet on top, but also enough solder to flow through and get a fillet on the bottom and top of the board. So I'm going to hit it again because I was sitting here talking. Here we go. Good connection is the key. Just a little bit more and pull off. I'm going to do the next one. Since I already did that side, what I need to do is clean the iron again. Remove the oxidation. Cut the end of my solder. Clean the solder. Remove the oxidation. And try again with the next side. Apply a little tin. Touch the pad and the lead. And feed, release. Tin my iron so I don't damage it. And now this looks good on this side, but I don't know if I got enough solder on the other side. So I'm going to flip it over and inspect the side to make sure I got good flow through. And then we'll have Jen read us the next steps. Clean the connection.
Clean the connection, step 6. Step 7 is your inspection. You want to make sure it's free of flux residue, smooth and non-porous, undisturbed and having a finish that may vary from a satin to a bright. Solder shall fillet between the connection element over the complete peripheral of the connection. Lead contours shall be visible. Solder shall flow through the plate, through hole, and bond to the lead and the solder pad on both sides of the PWB. Slight recessing and shrink back of the solder on a PTH below the solder pad is acceptable. Slight de-wetting of the solder around the peripheral.
Let's hold there for just 1 second.
Sure.
So while I look at this, she said the top, of course we're going to look at the top. I'm removing the flux, make sure I don't have enough flux. I'm looking for a good fillet on the top. I need to look at my glass for a second. That looks okay on top. And it also said it's a plated through board, so with the plated through hole, it mentioned shrink back. Can you read that? Read that again for us?
A slight recessing or shrink back of the solder onto the PTH below the solder pad is acceptable, providing the solder has wet the lead and on the solder pad.
Right. And so what that means is, when you add solder and it starts going through the hole, it's going to look really good, and then when it starts to cool, it shrinks back into the hole. So it's going to shrink back into the hole like this one. This end right here shrunk back into the hole, but there's still enough solder where it shows that it didn't de-wet. It didn't pull back and leave a gap. It didn't distort. And if you look, I don't know if you can see that very well.
Yeah, tilt that up. There you go. All right. Yeah.
You can look on the top of the resistor, and it did shrink back a little bit, but it's still fine. It's still within tolerance. The top, that is a nice fillet going to the top. And when you fill, if you put too much solder, what you'll see is the solder will flow up the lead, bunch up against the resistor. That's no good. Typically, when you do this, you don't want any solder to build up and accumulate in the bend of the resistor. That would be cause for rejection once it builds up enough and touches the body of the component. Plus, it's going to overheat it. While you're soldering, you typically do not want to go over 3 seconds. 3 seconds, anything over 3 seconds, when you hit 5, if the components are touchy, not like a resistor but like an IC, you can destroy the component. So in many cases you'll use a heat sink on a component like an IC. Now look at the bottom. The bottom has a nice fillet on both sides, and it's flowing nicely. Okay, go ahead and read the rest of the things we're looking for.
Slight de-wetting of the solder around the peripheral of the pad on the part side of the PWB is not caused by rejection.
Okay.
Cause for rejection, sir.
Okay, and that's what we looked at here. We are okay. And that's it. All right. And that is a plated through component, a resistor. Of course, a capacitor, inductor, those components would be exactly the same. You place the component, you angle your leads, clinch them, and then make your joint and look for the feed through on both sides of the lead. And that is it.
Tool time here. If you look down on the bench, we've got some side cutters, some long nose pliers, some more side cutters which are slightly better for our use here at Dilworth. These are meantime here, if you look down on the bench, we've got some side cutters, some long nose pliers, some more side cutters which are slightly better for our use here at Dilworth. These are some bent pliers for getting into little crevices, and these things are called outing nippers, which work really well as nail clippers as well. We've got two sorts of wire stripper here, which we can use. This one
Looks like a dinosaur.
this one looks like a dinosaur. This one is the flashier one, but it's harder to use and it breaks more easily. The other thing we need, of course, is solder. This is 5-core solder, and what that means is that within this tin and lead alloy mix, within this solder there is a cause a resin flux. Now, flux is a chemical way of cleaning the joint, and so when you heat up the solder, it melts the solder, and the flux resin melts too, flows out into the joint and cleans everything up and helps break down the surface tension. Over here we have an anti-static mat with a wrist strap. This is connected through to the soldering iron, which is connected to the earth. The reason for that is that static electricity can destroy microchips very easily, and so what Jesse will do now is just equip himself with the wristband and plug himself into the soldering iron. This mat is impregnated with graphite, which conducts, so if you put components on here, any static electricity that builds up. Okay.
Today we'll be fixing some electrical components with my friend Jesse here. Hello Jesse.
Hello.
So Jesse, should we get started? Strap yourself up. Bro, you forgot your eye protection.
Wipe it on the damp sponge, nice clean shiny end. Solder ready. Heat the joint, bring the solder in, enough to coat, and then solder out and heat out. So here we go, just bring the heat in, bring the solder in, 2, 3, solder out, heat out. Same here, heat in first, then the solder goes in. Just coat the end gently. You don't need tons of solder, you're not welding. Heat in, solder in. Ooh, shaky hands. Just run the soldering iron along, get the heat in first, then the solder will melt onto the copper, and you can drag that along just to give a thin coating. And that should be ready.
have some electronic circuit boards that have been thrown away. We're going to take the parts out of them. For example, this one has 4 bridge rectifiers in it. We can use that to put on a windmill or some other alternative energy product. This one just has a few diodes, a couple amp piece, and then some smaller diodes. Here we have some electronic circuit boards that have been thrown away. We're going to take the parts out of them. For example, this one has 4 bridge rectifiers in it. We can use that to put on a windmill or some other alternative energy product. This one just has a few diodes, a couple amp piece, and then some smaller diodes. We could take a bunch of diodes the same size. We'll go in and we'll check what voltage they'll handle. We'll put them together and we'll make our own bridge rectifier out of those. There's another one. Some capacitors. This one's a 50 volt capacitor. There's a 25 volt. If the voltage isn't high enough for what we need, we'll just put 2 of them together and give us a higher voltage. We don't know what amperage these bridges will hold or what voltage they are until we go in and look up the model number. We could actually leave the heatsink on there and they could handle the amperage better. There's some capacitors in there and another bridge here. There's another device on this one I found. A little tube used for arc suppression or lightning arrestor. Actually what they put in lightning arrestors. Here's a surge suppressor. Most people see that and they're going to say, hey, that's a capacitor. Well, that's not a capacitor, that's for surge suppression. Had another one here. Another one for surge suppression. Not sure what these are unless I actually go in and look them up. Here's some more. This one is 3 pins. This one has 2. That's actually gives you your neutral in the middle, your ground in the middle, your neutral on one side and your hot on the other. There's some more. What I'll do is I'll take some of the parts off of these and I'll reuse them. Nice resistors, 20 watts. Got some more with nice resistors on them. Now this is good for measuring the load. What you do is you put your voltage across it and then you measure what voltage you're actually getting. You take the ohms off of the resistor and you calculate the amperage. I've seen a lot of people take and measure the voltage with it open. Well, that's nice for telling me what the maximum possible voltage is, and then they take and short it out to give you the amperage. Shorting out and giving me amperage tells me nothing, because that's just shorted amperage. I can't measure anything with that. I can't tell what kind of power I'm going to get out of that because I don't know what the voltage is while it's shorted. Most likely the voltage when it's shorted is less than 1 volt. What I have is a soldering iron which has a sucker on it for desoldering. We call it desoldering iron. This one's actually an old one. The new ones are pump. You squeeze the trigger and it runs a pump. This one doesn't have a pump, it just has me squeezing it. What we do is we put it on here, we melt it, suck it up. And we'll pull it off the board. Now I'll do that for some more of these boards. Take the parts off of them. It'll take me a while. And then I can use the parts for something else. Now we've got a nice pile of components. Got some heat sinks and bridges off. Bridges here. And more heat sinks. Lots of capacitors. Some fuses. Some diodes. Got some small diodes. And we'll use those. Solder them to here. What I'll do with this is I'll build a voltage multiplier or a voltage doubler with those small diodes. Actually, what I found is some half-wave bridges off of computer power supply, and I'll use those. Got resistors. Found another bridge rectifier. Pulled off a battery, probably dead. Our lightning suppressor. There's another one in here somewhere. We'll find it later. And now we can build something.
Now that you're familiar with soldering tools, solder types, and fluxes, let's discuss the nuts and bolts of how to hand solder through-hole components onto printed circuit boards. Most production soldering is done with automated machines that can make hundreds of solder connections all at once. But there are some heat-sensitive components that can't handle the higher temperatures during wave soldering. Now that you're familiar with soldering tools, solder types, and fluxes, let's discuss the nuts and bolts of how to hand solder through-hole components onto printed circuit boards. Most production soldering is done with automated machines that can make hundreds of solder connections all at once. But there are some heat-sensitive components that can't handle the higher temperatures during wave soldering. Defective components may also need to be removed from the board after wave soldering, and a new component hand soldered back in its place. Regardless of the reason for soldering by hand, we need to be able to make a strong physical and electrical solder connection that will last. The hand soldering process should always begin by preparing or tinning the tip of the soldering iron. We explained earlier how oxidation forms on the surfaces of the metals to be soldered. This oxidation will also form on the tip of your soldering iron. Oxidation acts as a barrier or an insulator, which means that it can slow down the transfer of heat. An oxidized tip will prevent the rapid transfer of heat into the metals to be soldered. Notice the time difference between the properly tinned tip and an oxidized tip, melting a similar solder connection. To begin the tinning process, we'll take a hot soldering iron and wipe the tip 2 or 3 times across a damp sponge. This will remove impurities and oxidation, but it shouldn't cool the tip too much. If the tip is wiped excessively, if it's gouged around in the sponge, or if the sponge is too wet, the tip could become too cold to use for soldering or tinning. Now let's apply some flux cord solder onto the tip. The flux inside the solder will flow first and chemically reduce the oxides from the tip. Then the solder will flow over the tip and form a shiny coating. This tip is now properly tinned. Tinning is especially important on brand new soldering iron tips. Every time you install a new tip, it's important to tin it right away, or it may become untinnable and unusable. Tinning should be repeated as often as necessary. Whenever you can see that the tip is no longer clean and shiny, you've waited too long to re-tin. Heat can cause soldering iron tips to become so oxidized that they become unusable. It's a good practice to melt some solder onto the tip whenever you plan to let the iron set for any length of time. This solder coating will keep oxygen from reaching the metal tip to protect it from severe oxidation. It's also a good practice to turn the iron off when it won't be used for an extended period. On some irons, oxidation can also form on the barrel which is the area between the tip and the handle. If it's not removed, the oxidation on the barrel can also slow the transfer of heat to the tip and keep it from quickly reaching the soldering temperature. Oxidation can be removed from the barrel with fine abrasive or a wire brush. Brushing should be done away from the workstation surface to avoid contaminating your work area. After we've prepared the tip of the soldering iron, we should be ready to start the soldering operation. We'll be using a temperature-controlled soldering iron with a chisel tip. The temperature of the tip will be set at 315 degrees C. Our solder will be 6337 eutectic with a 0.5 millimeter diameter. The flux in the core of the solder will be type L or mildly activated. To demonstrate the basic technique, we'll be soldering a round component lead into a plated through hole. Normally, this type of soldering operation would only take a few seconds to complete, but we'll be stopping the process in order to explain everything that happens as we go along. We begin by gently placing the cleaned and tinned soldering iron tip against the lead and the land. This will transfer heat into both of these parts. Now the solder wire should quickly touch the tip of the iron to melt just enough solder and flux to form a heat bridge between the metals. Then we'll move the solder wire over to the opposite side of the joint, still touching both the lead and the land. When there's enough solder melted into the connection, the solder wire is removed, followed by the soldering iron tip. At this point, it's important to clean the connection if required. Then we'll inspect the joint to make sure it looks right. A preferred or target connection is where all of the metals are covered by solder and the outline of the lead remains visible within the solder connection. Here's what that same operation would look like at normal speed. Notice how quickly this all happens. Let's review the process once more to highlight some of the problems to avoid during hand soldering. The tip should lightly contact both parts to be soldered. Pressing down firmly with the tip will not transfer the heat faster, but it may damage the land or the base material. Only a small amount of solder should be melted against the tip of the iron. If you melt all the solder by touching it directly to the tip, you may not get enough solder to flow onto the other side of the connection. Remember that solder flows toward the heat, flux flows away. Another problem is melting too much or too little solder into the connection. If you don't remove the solder wire at the right time, you could end up with something that looks like this. This time we remove the iron tip before the solder wire. Now we'll have to reheat the joint in order to remove the solder wire. Notice what happens when we reheat a solder joint? It doesn't look as smooth or as shiny as it was before. Now let's see what happens when you reheat a solder joint using flux. In this case, the solder appears as smooth as it did before. Whenever you melt solder, you always need to add flux, either through the core of the solder wire or with an external applicator. Now let's look at the correct technique one more time. There's a lot happening in just a few seconds. The parts to be soldered are heated, cleaned by the flux, and joined together to form a physical and electrical connection.
We're filming this video in response to the question received from Alexander Turel. Alexander asked us, I recently come across many circuit boards with multiple planar components in SOI, KFP and BJA cases. What equipment is ideally suited for soldering such components in radio electronics, and how does one operate such equipment? We're filming this video in response to the question received from Alexander Turel. Alexander asked us, I recently come across many circuit boards with multiple planar components in SOI, KFP and BJA cases. What equipment is ideally suited for soldering such components in radio electronics, and how does one operate such equipment? We will now show you how to do that. It is indeed true that most of today's circuit boards use SMD components. For example, this circuit board has almost no deep components that have been widely used in the past. This circuit board can't be repaired using regular soldering iron and following traditional soldering methods. Our radio electronics amateurs, being representatives of the talented Russian people, use anything available for this purpose. Some even rebuild construction dryers for soldering SMD components. But I would like to emphasize one thing. Apart from being incredibly complicated and dangerous, this method also often leads to sad results for the circuit board itself. So it might be better to just use a specialized soldering station. For instance, hot air soldering is one of the best fitted methods for this application. Each microchip case has its own standard size, which is why special nozzles have been designed for each case. This makes soldering easier and prevents damage of the other components and of the microchip itself, since the air temperature is rather high. Now we'll show you how to use the hot air soldering station to unsolder this microchip with the SOP case. Let's turn on this soldering station. I have already selected the best nozzle for this case. We need to set the temperature. The temperature for each case and microchip is indicated in the specifications provided by the manufacturer of the microchip. So before you start soldering the microchip, make sure you have studied the respective reference data. I'm setting the temperature as required by the manufacturer and wait until the soldering station reaches that temperature. Before soldering the microchip, I will apply flux to prevent oxidation and make the soldering process easier. The soldering station has now reached the required mode. I have applied the flux, so we can start on soldering. But I would like also to point out that today's electronics is very sensitive to static electricity. So before we start working, we need to make sure that there is absolutely no static voltage coming from anywhere. That's why I will use an anti-static pad and put on an anti-static bracelet to make sure that nothing fails. At home, if you can't really use any anti-static material or tools, you have to at least make sure that your clothes are not synthetic, or that the clothes and the objects around cannot be electrified. Okay, so now I will unsolder the microchip. It will take some time. The soldering station is made in such a way that it heats up the soldering area, that is, the microchip terminals, so that the other components remain intact, and the case itself continues to be relatively cold, because the heating is concentrated above the microchip terminals only. So our solder has melted. I now use the tweezers or a special puller to remove the microchip. And hooray, the microchip can now be easily separated from the circuit board. All the checks remain intact, and which is more important, all the components that were located close to the soldering point are safe and working. So we have thus removed the old microchip. Now we'll use a regular soldering iron to clean the checks a bit. All the extra solder was removed together with the microchip, so there is virtually none left on the board itself. It's now time to solder the new microchip in place of the old one. To solder a microchip of the kind, we will need a special solder paste that contains flux, finely dispersed tin, and other additives. The paste is applied in a small thin layer. The microchip is rather thick, so I won't need any templates, and will just mark the tracks. But let us not forget that this has solder, so if we apply too much paste, we will end up with extra solder. Templates help to avoid this problem, but if you're doing this at home, like me, it's much easier to just do it the way we're doing it here. I have distributed the paste rather evenly. Don't be too concerned if some of the paste is visible between the tracks. The tracks won't get locked. When melting, the solder will accumulate on the terminals and tracks due to moisturizing. Now let's take the new microchip and put it onto the circuit board. It's important that the microchip is placed in such a way that the terminals correspond to the tracks exactly. This will ensure the high quality mounting. I have now mounted the microchip. The paste has some adhesive properties, so the microchip won't go anywhere. You can see for yourself that the quality of soldering is high. Everything is in place. Everything is working. We could use a magnifying glass to make sure, but I can see well enough to see it is definitely okay. So today we showed you how to use special equipment to easily replace seemingly very complex electronic components on a circuit board.
Soldering is not very hard. This video will cover the basic soldering techniques for electronic and electrical wiring. First, you need to get a pencil type soldering iron for this sort of work. Pencil soldering irons come in wattages from 20 to 60 watts and are generally inexpensive. Higher wattage irons generate more heat. I suggest a 30 to 40 watt pencil soldering iron for general purpose wiring and electronic repairs. I'm going to use this. Soldering is not very hard. This video will cover the basic soldering techniques for electronic and electrical wiring. First, you need to get a pencil type soldering iron for this sort of work. Pencil soldering irons come in wattages from 20 to 60 watts and are generally inexpensive. Higher wattage irons generate more heat. I suggest a 30 to 40 watt pencil soldering iron for general purpose wiring and electronic repairs. I'm going to use this 40 watt chisel tip Weller soldering iron today. You also need rosin core solder. Don't use any other kind of solder for wiring or electronics. This particular spool of solder comes from Radio Shack. It's 60% tin and 40% lead mix. There's also lead-free solder available if you're concerned about lead. Solder also comes in various diameters. This solder is 0.062 inches in diameter and I think is a pretty good choice for wiring and general purpose electronics use. Well, what I like to do, this is a 1 pound spool. It's a little large and hard to handle, so generally what I'll do is I'll unwind a section of the spool around my hand so that it's easier to handle. Now, the real secret to soldering is really just keeping the tip of your soldering iron tinned. Tinning is melting solder directly onto the tip of your soldering iron. And tinning prevents the tip from oxidizing, so you should always keep your soldering iron tip tinned. Tinning also ensures that the heat is efficiently transferred from the tip of the iron to the joint being soldered. Now to tin the soldering iron tip, you just melt solder directly onto the hot iron tip. But this is the only time you apply solder directly to the iron tip. You want fresh solder on the tip just before you actually solder. You need to make sure you clean the excess solder off the tip before adding new solder. Now, I've just tinned the tip here. I prefer to clean this excess solder off my tip onto a magazine or a scrap piece of paper like I have here. I just flick it like that and the excess solder comes off. Some soldering iron stands have sponges that you dampen and you can use to wipe off the excess solder. We first prepare the joint to be soldered. For this demonstration, I'm going to make an inline solder joint with stranded wire. First, you strip off about 3/4 inch of insulation off both ends of the wire, and then you twist the strands together on each end to make sure they're tight. Then, you overlap the wires about halfway and twist them onto each other in opposite directions to make this nice inline splice. Now when you're soldering wire connections, you always need to be sure to make a good physical connection before you solder. The alternative to this inline splice is a pigtail splice, which you just take the wires, lay them side by side, and then twist them together. I think the inline splice makes a nicer splice. That's why I'm going to do it that way in this demonstration. The next thing you do is you need to secure the wires before you try to solder it so it doesn't move around. I'm going to use this alligator clip third hand device. The first thing we do prior to soldering is tin the tip of the soldering iron. Then I knock off the excess solder and then lightly tin the tip again. I then place the tin tip of the soldering iron firmly against the wire. The idea is to use the iron to heat the wire, then melt the solder onto the heated wire. Never touch the solder to the tip of the iron while you're actually soldering. The solder only touches the joint you're soldering. As you can see, once the joint is heated up, the solder will flow onto the joint. Don't try to push or paste the solder onto the joint. Just touch the solder to the joint until it starts melting and let it flow onto the joint. A good solder joint will have solder completely melted onto it and be shiny silver. That's it.
Hello everyone, how's it going? This is Jack again, and I just wanted to share with you today what I'm working on down in the basement. And basically I'm trying to do BGA soldering, home-based BGA soldering. I have a new Papilio board. It's an experimental. This is it here, actually. And there's a quick look. Hello everyone, how's it going? This is Jack again, and I just wanted to share with you today what I'm working on down in the basement. And basically I'm trying to do BGA soldering, home-based BGA soldering. I have a new Papilio board. It's an experimental. This is it here, actually. And there's a quick look. Hello everyone, how's it going? This is Jack again, and I just wanted to share with you today what I'm working on down in the basement. And basically I'm trying to do BGA soldering, home-based BGA soldering. I have a new Papilio board. It's an experimental. This is it here, actually. And there's a quick look at it. But you can see that it uses a BGA chip. I actually assembled and soldered probably about 4 or 5 of them, and only one came out, so the yield wasn't very good. I think the problem was not enough heat. was applied. So I'm going to attempt it again. I'm going to try and repair this particular one here, and I'm going to pay more attention to the thermal profile this time. So please watch along with me. Okay, thanks. Okay, so the first step is we're going to go ahead and remove the BGA chip from the board. And I have my trusty, dusty pancake griddle. Bought it for $20 from Walmart, and it works wonders. So I do also owe a big thanks to SparkFun for the idea and tutorial for using they use a skillet, and I found pancake griddle works really great too. Okay, so right now we're just heating it up, and the goal is going to be to heat it up to the point where the solder balls are in a liquid state, and then I'm just going to use this little vacuum squeezy thing here to pull it off. Alright, now another thing that's pretty important is ventilation. So what I usually do is I have this fume remover or fume extractor, and then I also usually run a fan to blow the fumes. Now, if I have any trouble getting enough heat for the balls to liquefy, then I have a hot air soldering station. So we can use this to put a little extra heat. We'll use this to put a little extra heat on the BGA chip. Okay, so the board's been on the plate for about 2 minutes now. That's probably getting pretty close to where we need it to be. So I think the board's where we need it to be. Let's just give it a quick try here. I'm going to pin it down with a dental pick. And there it goes. Came right off. Alright. Okay, so now we have a board that has all the chips removed that we want to replace, but it's pretty much a mess right now. We've got a lot of solder paste on the pads, and so the next step is we're going to remove all that. So I'm going to start by putting a lot of flux on. I have this no clean flux here, but you can also just use flux that you get from Radio Shack. It's a lot messier, but it is actually more effective. So I usually start out with this non-clean stuff, and if it doesn't do the job, then I move to the more the hardcore resin-based stuff that it does an amazing job. Alright, so we've got the flux on, and now we're going to use some solder wick from Radio Shack, and I'm going to get my magnifying glass down here so I can see what's happening. Alright, so I started out with the water soluble flux, and I'm not really getting the results I like, so I'm going to graduate to the big guns, which is the resin-based flux. It's messy, so it requires a lot of cleaning of the board, but it really makes a difference when you're trying to wick something up to have this type of resin-based flux. Okay, well that resin Really made short work of it, but it did leave a nasty mess that you come to expect when you use that stuff. So it just makes it a little harder to clean it up, but I'll show you a trick that works really well with cleanup for that. Okay, so we have the chips removed, but we have this nasty mess left over by the resin. We need to clean it up. And the secret weapon is brake clean. So you can go to your auto parts cleaner, or you can go to your auto parts store, get yourself a bottle of brake clean, and it will take this grease-based resin right off. Won't harm the circuit board. Works pretty well. Not something I'd recommend using for anything other than prototypes, but when you want to get it cleaned up quick, it does the job. Now you also want to make sure you have good ventilation. This stuff is smells pretty bad. Okay, so you're going to want to follow up once you've gone over it with brake clean and you've got all of it looks pretty degreased. There's a lot of talk out there that the degreasers and that sort of thing will actually cause shorts between pins and that sort of thing. So I always follow up with a good thorough cleaning with just standard isopropyl alcohol. Anything over 90% is good. The more over 90% you can get, so more like 99%, is even better. And voila, we have a board that's pretty clean. I'd probably actually, well, I was going to say I'd probably eat off of it, but you know, there's been brake clean on it and whatnot, so I probably wouldn't do that. But I would certainly put a BGA chip on there. So moving along, we have a clean PCB and it's ready for the FT2232 chip and a new BGA chip. So we're going to start out by, I've got some solder paste, and this is solder paste in a syringe, and I'm just going to lay down a bead of solder paste on the pins for the FT2232. And so I just do a straight, you know, I'm not worried about how much I'm putting on there because we're going to clean it up later. So I just put, you know, a straight bead across each row of pins, and that's really all you have to do because we'll clean it up later. Alright, so I've got the FTDDI chip ready. I'm just going to set it down here, and I'm going to use my little vacuum picker to take it out, put it right on there, and then I just use a dental pick and a magnifying glass to place it. And also I use tweezers to hold down the PCB. So you don't have to get it perfect, you just want to get it lined up the best you can, because surface tension of the solder is actually going to pull it into place and help with the alignment. Alright, so now that that's ready, we've got the BGA, the Spartan BGA chips. We're going to place that. So the first thing we want to do is we've got some water soluble flux. This is going to help reflow the pins or the pads, the BGA balls onto the pads. So we're going to apply a generous amount of this, and we're just putting it over all the BGA pads on the board. So the next step is to place one of these BGA pins or BGA chips. And for this, I'm simply, once again, using the vacuum pickup tool. Just dropping it, and this is where you want to be a little careful and hope that your silkscreen markings are good to help you align the chip on it. Now once again, you want to get this as close as you can, but surface tension should suck it into place. Okay, so we're ready to proceed here with adding heat, and I looked at the Xilinx data sheets at the thermal profile, and what I saw is that we should have about 2 to 2.5 minutes of preheat and drying time, where we want the temperature to be around 350 degrees, and then we need a 1 to 1.5 minute wetting time, where the temperature should be between 400 and 420 degrees Fahrenheit, and we don't want it to exceed 430 degrees. I'm just going to kind of eyeball this, and I'm using a stopwatch timer on the Android phone, and we'll see how it goes. So I'm applying heat now. I'm turning it up to 350, and we will start the timer and be back in 2.5 minutes. Okay, as you can see, we just hit 2.5 minutes. I'm going to reset the timer, and we're going to enter the wetting phase, which should be 1.5 minutes. And I'm also, I'm going to turn up the temperature all the way to the max, 400 degrees Fahrenheit. And I'm also going to use my hot air gun to just provide a little more temperature. We want to do this for 1.5 minutes. Okay, so it's been more than 1.5 minutes, but it just doesn't feel like it's quite ready yet, so we're going to leave it on just a little bit longer. I think that the ramp up time probably took much longer to reach 350 degrees, so I'm going to leave it a little bit longer. Okay, so we've been on a little bit longer than the recommended thermal profile, but I think that it looks good now, and I'm going to remove the heat. I'm going to turn the heat off, and we're going to let it ramp down on the skillet so that it doesn't provide thermal shock if we take it off. Okay, so now I'm holding this up, and hopefully you can see that the BGA chip's on there. It's aligned pretty well, but there's a lot of solder bridges on the FTDI chip, so we're going to clean those up now. So we've got the soldering station, and the best way to clean these up is to use some soldering wick. And once again, use your flux. So put flux all over the pins, and simply use your solder wick to clean it up. Now, one thing that I'm doing that I'm not really talking about is, one thing that you can do also while you're using the solder wick to clean this up is use a drag technique. So you start at one edge of the pins, and you use your soldering iron. To drag the solder from one side to the other. It'll collect it all on one side, and then you just use your solder wick to wick it all up. Okay, so there we go. I'm going to hold it up, and let's see if it'll focus in on it. And those pins look like they're ready to go, and there are no solder bridges anymore, so it's pretty easy to clean that up. Alright, so we're back and all the soldering's done, and the board's ready to go. The BGA chip has been replaced. Visually it looks right. Looks like all the pads are connected that you can see from the side. And we're going to connect it to the computer, see if any smoke comes out. Hopefully not. And then we'll run a test with the AVR8 soft processor to see if it's behaving like it should. So here we go, about to apply power to the newly resoldered board, and let's see what happens. Alright, it looks good. No heat. So I think it looks good. This is what it's supposed to be doing. And let's just pan up to the computer. I've got the Papilio Quick Start ready to go. Let's upload it to the board. Now this is using a custom, a modified version of the AVR8 soft processor to accommodate the new board. It's just really UCF file changes. Uploading to the board. Sometimes it takes a while. Sometimes it's really fast. Depends on what the computer's doing, I guess. Alright, well, that's cool. So looking back at the board, that blue light indicates that we do have a program bit file, and the blinking light is for the serial ports. So let's go back and let's hit up the serial monitor and see if it's transferring the ASCII table. And it is. Alright, so in summary, I think that we just did some initial testing, but the initial testing shows that we at least got power. So power and ground pins all seem to be soldered and working correctly, and we're transferring serial information, so the serial pins are connected properly. We haven't done complete testing of the I/O pins or the connections to the SRAM chip, but I'm pretty optimistic that they'll be fine. I'll give an update if they're not. And just to prove that it's not a fluke, I actually made 2 of them. I did another one with the same technique, and it's behaving the exact same way. So I think that this is proving that you can solder BGA chips at home on your pancake griddle. So anyway, thanks for watching, and I hope you enjoyed it. Okay, bye.
Now I'm going to be assuming that you've seen either all of or part of my original JTAG series, because the information there will be quite valuable here if you don't quite understand it. Bear in mind this is going to be a one-shot video, so it's only covering the soldering from an intermediate level. That being compared with the kind of the noob-ish method I tried to substitute for the original, because people were not going to have necessarily the hardware required for this, and probably most won't have now. But I'm not going to cover disassembling this thing. I'm just going to basically strip it apart, and I'll cut to somewhere when it's already in pieces and we can begin work. Torque 8, other flathead screwdriver, iron tinner, solder, first person to try and correct the pronunciation dies, stand for iron, and the iron itself. Okay, so today we're going to be working with these points right here, and if we look over to the side, a few of these ones. Now I apologize if the focus is not quite perfect. I'm using a wide angle lens, and as you can imagine it's not designed for close-up shots. So we're going to start off by getting our iron ready. This iron is actually cold right now. Pain. Right, you'll also want to clean off the area. You can use rubbing alcohol if you want. I'm not going to, because this is a dead motherboard to begin with. Okay, so relatively straightforward. Once your iron has heated up, you just stick it into your solution there and give it a coating. Just the top of the iron. Get rid of any excess on your sponge there, and that'll do it. Sorry about the shadows. I have really high aperture on the camera, so there's going to be really high contrast. So we just take our solder here, stick the iron into the point, bring in the solder, and you just tin the first point there. Don't worry about the flux burn. First point is done there. You may want to get rid of the excess solder from your iron. That's why you have your sponge over there. And move on to the next one. Stick the soldering iron in and bring down the solder. Now with this you want to be very careful that you don't leave your iron in there too long and damage the point, because that would be horrible. If you're seeing an insane amount of flux burn there, that is actually just the camera. There's practically none here. I don't know what's going on there. I'm hoping you can see this well, but you can see there we just bring the iron in, add the solder to the point. Simple enough. Third point, set the iron down. Just want to be very careful with this. I'm doing this in the wrong order, because otherwise the angle would be insane. I'll try to show a different angle here. The angle is very difficult for me to actually show you this properly. So you take your iron here, you stick it down into the point. You need to have a needle tip iron for this to work properly now. So you heat the solder or the point, and you bring in the new solder. And the first point is now tinned there. That one's done. Third point, solder. That one is done. Next one, Sorry, my hand's shaking. I'm holding this at a really weird angle. I can barely actually see where I'm putting this. Okay. Next point. Next point. Okay, I really hope you can actually see this. I have to hold the camera with the anti-shake on. You should be able to see the completed points in there, but I can't be sure. As you can see, the greatly exaggerated flux burn earlier is quite literally nothing at all. It turns out the liquid, the flux was actually glowing or reflecting the light from above it, so dark areas were quite literally completely black, which I'm going to try to see if I can prevent that from happening again in the future. But I'll show you how to insert the wires properly next, which is extremely easy to do if you have the right soldering iron. Okay, how do you get the wiring? That being this really tiny wire here, which is out of focus and blurry. Now, my battery on the camera light is blinking red. Okay, that made no sense, but if this battery dies during this video, it'll be the first and loudest time you've ever heard me exclaim profanely in a video. But let's get going. So, you got your iron here. You want to stick the iron into the solder you added in earlier, heat it up, followed by your wire. You have one connection, perfect. If you want, you can dump more solder on top of the wire to help you out there. I'll cover another point just to show you again. You have a point in there. Bring the soldering iron in, bring the wire in, and stick the wire into your point. Can barely see this, I'm very sorry. There we go. Don't want to put it in too far, it's a very long wire. So there's really nothing to this if you have the right soldering iron and of course the necessities. Now the same thing goes of course for your resistors, which you can see here, I hope. So if you get another point over here, where is that thing gone to? Blasted, I'm in a hurry here, come on. Alright, so got one point in there, which I also hope you can see. You grab your iron, stick it in there, take your resistor, put that in. There we go, connection done with. Like I said before, you got optional, you can add more solder on top of that if you want. So heat the wire and the point, feed in more solder, and you got a beautifully strong connection. Now, as for connecting the resistors to wires, to extend them, that's also quite easy. I'll show you that now. So we got a resistor here, we got our wire here. You want to make sure you've got quite a bit of copper on your wire there exposed. So you grab your wire, wrap it around, well, slightly wrap it around your resistor leg, which should ideally be not too long. That'll do for our purposes. Grab your soldering iron, grab some solder, and stick your iron below your wire, and you just go feed some solder onto that. Just give it a nice coating. Sorry about all that clouds up there. And there you go, you've got a nice connection in there. And my camera battery just died at the end of my sentence. I'm so thankful it waited. Anyway, so this connection here is not entirely perfect. It's good, but it'll work for your purposes. This particular method of applying solder to the wire and the resistor might be better suited to stranded wires. In an ideal case, you'd want to shorten the leg of the resistor, maybe shorten the wire a bit, and you could possibly, if you intend to leave the wire in the console as part of the JTAG connectors, you might want to apply a rubber shrink insulator to it, and that would do for that. In addition, I recommend against clipping these wires after you have actually soldered them, because you may damage the integrity of the solder, and that could have repercussions down the line in terms of reliability. But that's the basic connection there for you. So today we've covered how to actually get your points filled up with solder. There are of course multiple ways of doing that too. We've covered how to insert your wires relatively easily, how to get them back out again, well that's kind of obvious, and how to attach a wire to a resistor, which as far as I can remember were I think the primary questions asked in relation to the original JTAG tutorial. So I think that's about everything I need to cover today. Also, before someone gets the idea to ask, as they inevitably do, about what the name of the song in the beginning of the video is, I'll tell you in advance. Save myself a few thousand lines of comment replies. The track is Let's Spin Wildly, which could be slightly mistranslated, I'm not entirely sure, by Supercell. I'd highly recommend having a listen to some of their tracks. Bought the album recently, very unique music. But anyway, thanks a lot for watching. I hope you found this video insightful, and I'll see you next time. Live long and prosper. You can't see that. Never mind.
Hi, this is Tanner from electronics123.com, and this is the first of our how-to video series. In this video I'm going to show you everything you need to know about soldering to put together most of the kits that we sell at electronics123.com. Basically, I'll first go over some of the equipment that you need to have to solder. These can all be purchased on our website. The first thing I recommend is a soldering iron, and we got one here. This is a 25-watt soldering iron. Hi, this is Tanner from electronics123.com, and this is the first of our how-to video series. In this video I'm going to show you everything you need to know about soldering to put together most of the kits that we sell at electronics123.com. Basically, I'll first go over some of the equipment that you need to have to solder. These can all be purchased on our website. The first thing I recommend is a soldering iron, and we got one here. This is a 25-watt soldering iron. This is what I use for all my soldering. They're fairly inexpensive, and they do the job. You don't want to go with anything that's much more powerful than 25 watts. I had a 40 watt at one point, and it was too hot. It was damaging some of the components. It's a good idea to have a soldering stand. Something to clean the tip of your soldering iron with. You don't want to get too much forming on the end of the tip, because it'll wear it out faster, and you'll have dry joints and so on. And also a good thing to have is a desoldering pump in case you make mistakes when you're soldering. And last, and most certainly not least, is a good set of goggles or some kind of eye protection. You know, if you have any air bubbles in your solder, you can get popping, and it'll send droplets of solder. You definitely don't want to get any of that in your eyes, so that's an important thing. Yeah, in this video I'm going to go ahead and work with one of our kits. This is a K141 or CPS141 on our website. It's a multi-mode timer. Really cool kit. Check it out on our website. So let's get started. Once you've prepared your workspace and have allowed your soldering iron to heat for 5 to 10 minutes, you're ready to begin soldering. The first thing you need to do is tin the tip of your soldering iron. To do this, you're going to apply a thin layer of solder to the tip. You do not want a droplet to form. If you get a droplet, clean the tip, but allow the shiny thin layer of solder to remain. Now, if we look at this board, I've attached several components. I'm going to go ahead and solder this resistor that's connected here. What you want to do when you begin soldering is first you're going to apply the soldering iron to the work, and then you'll apply the solder. You do not want to apply solder to the soldering iron and then try and move that to the work. You'll end up with difficulty, and you could get dry joints. So for this component, I'll just apply the heat, and you don't want to apply it for too long, but a little bit doesn't hurt. And then apply the solder. When I remove that, we see that we have a clean joint that looks good and will ultimately make a good contact. We can move on to the next joint. Here's one here. If you end up with droplets on your soldering iron, it's always good to clean that. First apply the soldering iron, and then the solder. So you're heating the work and then applying the solder to the work. You're basically melting the solder on the component, or on the joint between the board and the component. If you make a mistake when you're soldering, and I have one right here, you can remove it by using a desoldering pump. Now, desoldering pumps are fairly inexpensive and easy to use. and I can demonstrate one here. This is our desoldering pump. I think this ranges between $1 and $3, fairly inexpensive, but basically how it works is you press down on the plunger and then you press the button when you want to pull up the solder. And I'll show you here. I'll clean the contact on this board. Basically, prepare this. And all you're going to do is heat the solder, apply this, and press the button, and the contact is clean. I can now put a new component through that and then resolder it. Many kits contain integrated circuits, or ICs. These small chips are very sensitive to heat. It is important that when you attach these chips to the board you use a socket, because the heat from the soldering iron will damage the chip. So you attach the socket first, solder all of the pins down to the board, and then allow it to cool before connecting the IC chip. Sometimes you end up with contact points that are very close to one another. It is important that you don't allow two solder joints, to touch one another. When they do, this is called a short circuit. A short circuit allows electrical current to run in places where it shouldn't, and ultimately doesn't allow the circuit to complete its objective.
My name is John Gamble. I'm a certified IPC trainer and hand soldering specialist at Dakota County Technical College in Rosemount, Minnesota. Do you want the very best training in the industry for hand soldering for electronic assemblies? Let DCTC provide you with a solution to your soldering technology needs. My name is John Gamble. I'm a certified IPC trainer and hand soldering specialist at Dakota County Technical College in Rosemount, Minnesota. Do you want the very best training in the industry for hand soldering for electronic assemblies? Let DCTC provide you with a solution to your soldering technology
This is Barry from GuitarPCB.com, and I'm going to show you how to wire up some pots. Basically what I do is I start out with a short piece of wire, maybe 2.5 inches long, and strip just a bit off the end, like so. Once I do that, and I have enough to cover all the pots that I'm going to need, this is Barry from GuitarPCB.com, and I'm going to show you how to wire up some pots. Basically what I do is I start out with a short piece of wire, maybe 2.5 inches long, and strip just a bit off the end, like so. Once I do that, and I have enough to cover all the pots that I'm going to need, I take this bit and I bend it back. Like so. Once I do that, I take my pot and my solder lug and I run this wire through so it catches in there, and pull it back to the point and set it down on my work area. Pull it snug to the V, and I take the tip of my finger and I push down and around to kind of give it a good solid mechanical connection. Okay, once I do that, the wire kind of holds there on its own. I take my solder and my soldering iron and I go ahead and secure it with some solder to the lug. I'm going to go ahead and finish this up. And there we go. Once I have my wires, and obviously I measured one of them wrong, so I'm going to go ahead and even those out. What I like to do, but it's not necessary, is grab some heat shrink and cut off 3 pieces of the same size. Put them over. Push them down over the lug. Like so. You end up with something like that. Once you have that, then you can go ahead and use your torch or lighter, whatever it is you're using, and apply a little heat to it without burning it, both sides, and you end up with something like that. That's a finished one. And of course, once you finish all 4, you can go ahead and solder them into your circuit where they need to go. And after you're finished that, what I like to do is add some of my pot condoms that I designed, which protect the back of the circuit from hitting off the pot. They look like this. They're pre-made. You can get them off of my site. You put the either red or blue backing piece inside, then take the whole thing, place it over and press down onto the pot, and they fit on there very snugly. So as you can see, you have a very nice protective potentiometer to go ahead and install into your enclosure. This way, when the back of the circuit comes down and sits against it, you're not going to have any trouble with the copper side of the circuit shorting out against the back of the pot. Plus, I don't know, they just look cool. I hope that helps, and thanks for watching.
So the first thing to do to make soldering is to pre-tin the wires or the pieces that you want to solder. So first of all, you have to clean the tip of the soldering iron. So a lot of people are using a sponge, a wet sponge, but I prefer to use some So the first thing to do to make soldering is to pre-tin the wires or the pieces that you want to solder. So first of all, you have to clean the tip of the soldering iron. So a lot of people are using a sponge, a wet sponge, but I prefer to use some fabric or some like disposable tissues and to wipe the soldering away. Then I'm using soldering, of course. So this one is a multi-core soldering. It's a special low temperature soldering. It's pretty cool because it melts only at 420 degrees. I mean, it melts at lower temperature than that, but 400 basically degrees centigrades is the proper temperature to work with it, and it's not too high, so it's not risky to solder sensitive parts at that temperature. So the key to good solder joint is to pre-tin the wire or the piece that you want to solder. So pre-tin means that you're going to melt some soldering and to put it on the copper of the wire, for instance. So I'm going to do that right here. And I'm passing the iron on the wire and I'm melting soldering at the same time. And now the result is it's not copper color anymore, it's tin. So I'm going to do the same, of course, for the second wire I want to solder. And this is really the key, because soldering is a metal that will melt at low temperature, and it's going to match with the other part that you want to solder. So I have only two hands, so I'm going to use my fingers, hopefully, to do that. I'm going to solder both, and as you can see, it will melt instantly and the soldering is done in less than a second. And the key is to pre-tin both parts. It's very important to do it on both parts and not only on a single part. So now we're going to see how it works when you want to solder a part on a board. So I have an old circuit board, well, dirty board I've made in the past, and it has some little square pads, solder pads in here, which are supposed to be pre-tin too, but I have to put some more soldering on it. So to proper soldering, you have to make sure that the part you're going to solder or on which you're going to put soldering is at the proper temperature. So it's not going to work if you simply put soldering and then you expect that it's going to work like that. It will make something which is close to mud soldering. I mean, it's not liquid. It's a bit like a paste, and the aspect is not shiny at all. It looks dirty, it's not very bright. So the good way to do it is to heat the pad, and then I had the soldering on the pad, which is at the proper temperature, and it's going to melt very quickly, and it's going to make a very shiny solder joint. Oops. And you can see the difference, hopefully. It's shiny and it's bumpy as well, which is a sign of a good soldering. It has to be shiny and round, and soldering has to really melt and flow on the pad. I'm going to make another one on the side of it, and here we go. I have a second one, and if I use capillarity to make the solder joint communicating, I'm going to put the third one here, and then I'm going to add soldering, and you can see, hup, I made bridge, and oops, and a second bridge. Oh, it's too hot. Full bridge. So now, if I want to solder a part or a wire, I'm going to remove that soldering. Another rule, always add new soldering, fresh soldering, if you want to make something clean. Means that if you are, for instance, removing a solder between two wires, then you want to add fresh soldering on it first before making the next soldering, because it's adding some flow. I mean, inside the soldering, you have a core made of resin, and it's cleaning flow, so it's cleaning the surface on which you apply the soldering, and it's very important so that the soldering is clean, and the surface on which you put the soldering is clean too. So now I'm going to, for instance, to make another zone, and here, and then I'm going to solder, and it's done in 1 second. If I want to solder this little capacitance, for instance, capacitor, then same thing. I'm going to put in here. Oh, passing the tip like that is a good thing, because it's spreading the heat on the whole terminal. Of course, you shouldn't do that too long, because it's going to eat the whole part, but it's a nice way to make sure that the soldering is melting properly, and it's applied and spread on the whole terminal. It's not just a drop of soldering. There we go. And I have, as you can see, if the focus goes there, I'm not sure, you have two little drops, but it's shiny and round. So now I'm going to solder that on the bridge I made 2 minutes ago, and it's done. So now, if I want to solder the capacitor on another zone, the terminal is pretty thin, and I don't have soldering yet on the pad, but I'm going to start by putting some soldering on the pad, and the whole thing is going to melt in a second. I'm going to try to do that in real time in front of the camera. There we go. And it's done. So this kind of practice board is very useful, because you can exercise yourself doing some soldering. It's a very convenient way to experiment, but you can use pieces of wires, little rods of copper. You have plenty of solution. You can, like I often do, use some copper wire out of a transformer that you simply cut from the coil, and you have plenty of solution techniques. But so the basic things that you should remember are put in the parts that you want to solder, and make sure to heat both parts before soldering them together. So
guys, and welcome back to Tech Tips. Today I'm going to talk a little bit about soldering. About a week ago somebody brought a faulty speed controller to me, and it turned out to be that the solder joint on the plug was the problem, not the actual. Hi guys, and welcome back to Tech Tips. Today I'm going to talk a little bit about soldering. About a week ago somebody brought a faulty speed controller to me, and it turned out to be that the solder joint on the plug was the problem, not the actual speed controller. So solder joints and soldering principles are, in our hobby, I would think is very important, especially if you work with electric stuff. Okay, so without further ado, let's just start by talk a bit about the equipment you use. It is a fact that when you solder or do soldering joints, that the equipment unfortunately is trivial in how your solder joint comes out. For instance, if you buy a 25 Rand soldering iron and do a solder joint, and you do that same soldering joint with a 300 Rand or 400 Rand soldering iron like a Weller, you will definitely notice the difference in the solder joints. I prefer to use a temperature controlled base station like this one. You can see I can set the temperature and I can see the temperature there. The reason why I do that is because it's temperature controlled. I can solder anything from small components that fit on a PC board like this to bigger connectors like this, and even bigger connectors like the EC5 happily solders with a base station like this. Also very nice, the tips are interchangeable, which is very great because sometimes when you do surface mount stuff you can use a smaller tip, and yeah, you don't need to change the soldering iron for that. Okay, the next thing I want to talk about is the solder. Now, I always have a discussion with people about solder for the simple reason that everybody thinks that you go down to your local hardware shop and you buy a roll of solder and that's fine. I have a big problem with that because experience has told me that doesn't work as well as solder that you would buy from an electronic outlet. I know that there's solder sold on the Wi-Fi site. That solder I've tried and it is fine. But try and avoid these cheap solder that you buy from the hardware stores. Okay. Your solder must always be clean. As you can see, I don't know if you can notice, but the solder is actually nice and shiny. That is the way it should be. It shouldn't be dull. If it's dull, it means it's corroded. I do not use corroded solder because that causes dry joints. Dry joints basically is joints of solder that's not doesn't bind properly on the wires and your soldering joints. Okay. The other thing that I want to show you is this little piece of sponge. Now, this piece of sponge is very necessary. For those who wonder what type of sponge it is, this is actually just standard these sponges that the women use to clean their face with, and it works very well, and I use it to clean my tip. Okay. The reason for that is it's part of the 2 rules for working with soldering irons. The 2 rules basically is make it neat, make it clean. Okay, so always clean properly and always keep your solder joints neat. If it's neat and if it's clean, it'll probably be a good solder joint. Okay, so I'm just going to do a quick demonstration for you on how to go about doing a solder joint, and I'm going to start off with doing a wire join on the pad of this little PC board. Okay, this PC board is nothing serious, it's just a PC board I've got lying around, and yes, I'm going to solder this piece of wire onto the PC board here. Okay, right, now the first thing you want to do is just get a piece of solder ready. And I use this piece of tweezer as a second hand just to hold the solder. Now the first thing, when you join 2 pieces, both pieces needs to be tinned. Okay, If I were just to tin the PC board and then place the wire onto the PC board and try and solder it like that, by the time that the solder moves through the wire to give a decent solder joint, the flux would be gone and you would start getting sharp tips going out of your solder joint. Okay, so the first thing I'm going to do is I'm going to tin the wire. Okay, just put a piece of solder on the soldering iron and you see it starts smoking nicely. I clean my soldering iron. I check that my wire is clean, and by pressing the solder against the wire, first the heat, then the solder. Okay, and you see I move the solder on the actual piece of wire. Okay, I clean my soldering iron again, and what I'm going to do now is just put a piece of solder on the PC board. Okay, so first the heat, then the solder. Keep the heat there a bit, and there's a nice perfect round blob on the PC board. Okay. The second thing is I'm going to just very quickly just make sure my wire length is correct, and I'm going to cut a piece off. Okay. Then clean the soldering iron again and put heat, and then the little piece of wire. Okay, and there she goes. Perfect join. I'm just going to try and move it closer for you, and you can see perfect join there on the PC board. Okay, so again, let us just walk through the steps again. I take my piece of wire, clean my soldering iron, first put the heat on the wire, then the solder, and then tin the piece of wire. There we go. Cleaning the soldering iron again, and let's use the other little pad there. First the heat, then the solder. Okay, there's a nice perfect little blob. I'm going to just shorten this little wire a bit. Okay, first the heat, then the wire. Keep the heat a little bit, and then just take it away. And one more time. Very nice little solder joint on the PC board there. Just one thing, these wires, they can get quite hot, especially when you do the connectors. The wires actually gets extremely hot. The one thing you should never do is blow on your solder joint. I know it sets quicker if you blow on it, but what could happen is you can get a dry solder joint there because the joint actually cools down too quickly. So don't blow on your solder joint. If you're worried that you're going to burn your fingers, use a pair of pliers to hold the wire, or something to that nature. Okay, right. So I'm just going to demonstrate this now on a connector. What I'm doing now is basically, sometimes these connectors get a little bit hot and they melt. So I just stick it in there. So if it melts, then at least it stays in place. And then I use my tweezer, my collapsible tweezer, auto collapse tweezer, to hold the connector. Okay, so the first thing that I want to do is I want to tin my wire one more time, clean the soldering iron, same procedure, first the heat, then the solder. Okay, now this is quite a thicker piece of wire, so this is going to take a bit longer. Make sure that the solder runs all the way through the wire, all the way through. Okay, right, there's a nicely tinned piece of wire. Okay, so you can see the wire is tinned all the way through. Okay, next I'm going to put my blob on the connector. Okay, first the heat, then the solder. Okay, and you're going to wait until it gets hot enough to flow, and just keep very little bit on at a time. Add a little bit of solder to keep the flux in there. Okay, right. So my blob is now on the connector, and I'm going to try and show you the blob. I hope you can see that. Nice round blob on there. Okay. So now measure my wire, and I see I've got to snip off a little piece, as so. Try and work neat. Okay, and sometimes you need 10 fingers to do one job, but that's all part of soldering. Okay, now over here I'm first going to heat the blob a little bit, and then bring the wire in. Okay, and then It's got to heat up properly. It's got to heat up properly. It's got to flow properly. Okay. Actually, you know what I'm going to do? This is a very good example. As you can see on the side there, you can see that the solder has become uneven. It is not a nice round blob. That's a very good indication that I ran out of flux inside my solder. So that's very easy to fix without burning my fingers. I'm going to do this now. I'm just going to bring the soldering iron next to it and give it a piece of flux, a piece of solder. Okay, and now you can see. It's a nice round solder blob that I've got around it. Okay. Now, if it makes sharp edges, sharp points, then your soldering joint is not going to be adequate. Okay. So in short, this is just basically a very short tutorial on how to do how to solder. And just very quickly to recap, make sure that you have a proper soldering iron. Make sure that you have proper solder. Always work neat and always work clean. Sometimes you get PC boards that's dirty. You can clean them with a toothbrush and some methylated spirits. If it's very oily, then use a little bit of thinners just to clean it off, but then wash it off again afterwards with some methylated spirits. Even the connectors, if you find that they are very corroded, use a toothbrush and give them a good scrub with some thinners, and then wash it off with methylated spirits, and then the soldering joint should be alright. Just remember that dirty wires and connectors makes bad solder joints. A bad solder joint on your connector will actually cause it to heat up and melt. So yeah, always work clean, always work neat, and if you follow those simple rules, you should not have any problems doing any type of soldering. Yeah, so that's basically just a very short tutorial on how to solder. Thanks for joining me, and see you guys next time.
Take me up.